This will be a new series of videos that I'm going to be putting out. I'm going to be comparing 18 different handheld meters to determine which one of them is the most robust. And we're going to accomplish that using a new transient generator that I developed. A member of the EEVBLOG community, 5KY, graciously donated 15 meters that he purchased out of pocket. And he did a full review for each one of those meters. And I've linked his YouTube account in the description. So if you're looking for more information on the meters that we're going to be testing, I suggest you go to his site. He's done a very good job with those reviews, very thorough. I have some meters of my own that I plan on running against the 15 that 5KY sent. There's the Fluke 101. This meter was the winner of the $50 shootout that I had done. This meter has never been apart. Still works flawlessly, no problem. There's this Unity UT90A. This meter made it down to the final 4 and then was damaged. It's since been repaired. We're going to use this basically to try to get a baseline of how 5KY's meters compare against the original that I had tested. So I'm expecting to damage this meter during the test, just to be clear, but not until hopefully later on in the testing. But we'll find out. So many people had asked about the new Bryman that I purchased. This is a BM869S. I've been using this meter for the last 3 weeks or so. I used it to help develop this transient generator. I like it a lot. It's got a lot of features. It's very easy to use. No real issues. I was kind of concerned about battery life. I have yet to change the battery, and this meter's been in use pretty much every day. So very nice meter. This meter cost about $230 shipped to the United States from Poland. I don't think any of the meters that we have are even half the price of what this meter costs. So it'll be interesting to see how this stacks up against the other ones. One of the meters I would have liked to have run for this testing would have been the 87V. It'd be interesting to see how that compared against this Bryman during these tests, but I don't have access to another one, and even if I did, after damaging the first one, it'd have to be a freebie, I think, at this point to run it again. So the 87V won't be part of this test, but the Bryman here will be. So yeah, I'd like to thank 5KY for his generous donation of these meters. Again, that's all paid for out of his own pocket. I can't thank him enough. I mean, that says a lot. Somebody's going to be willing to do something like that for the community. So hopefully we all learn something from the meters that he's purchased and donated. So the meters arrived today. Again, a big thanks to 5KY for sending these out to us. My guess is this is one of the top contenders here. It's the Amprobe 530. If it works anything like the Amprobe 510, that's going to go a long way. And the other one here is the Fluke 107. If that acts anything like the Fluke 101, this is probably going to be the finalist. But we'll find out. So here's all 14 meters. I've gone ahead and functionally tested each and every one of these. Everything now appears to be fine. There is a problem with this hold peak, but it appears to be a software bug actually. We're going to go ahead and run it anyway. And my plan here is to run this Unity that I had ran before. That meter made it into the top 4. I have since repaired that meter, and it's been calibrated. It's fully functional. I had made some mods to it. I pulled those off, so that meter is basically back to stock. And the reason I want to run it is because that'll give us some kind of an idea of how to correlate these meters to the previous set that I had ran. We're also going to rerun the Fluke 101, and of course my favorite meter, my Bryman here that I got. This is the BM869S. So the first test we're going to do is with this piezo grill starter. We're going to apply a high voltage to the input terminals, and we'll run each meter through all the functions, and then we'll verify functionality. Wow. Looks like it came back. See that thing reset there. Wow. That's pretty bad. Wow, really? Oh, looks like it recovered. Wow, really? Wow, that is a shitty continuity tester. Wow, that is slow. Alright. Wow. Really? Reset. Some of these are pretty shitty. Wow. Looks like we killed it. It's dead. Yep. It will not fire up. Look at that. Wow. That's shitty. Wow. Same thing. Killed it. Look at that. Took out the front end of it. For the next test, I'm going to apply the maximum DC voltage while it's in DC mode. This meter happens to be rated for 1000 volts. That's the most I can get out of my power supply right there. Looks like it's only good for 600 volts max, somewhere around there. Right there, about 650. Doesn't seem to cause any problems with it. Damn common. Don't they know to put the common on the left? Yeah, I'm not sure with this meter. It says 300 volts max on this input, and it says Cat to 600. Let's just see what it'll take here. Certainly takes 300. There's 600. 700. What do they got to worry about? Full load right there, no problem. Just like the 101. Probably about the same voltage. Let's see. Yep, about 650 volts. It overranges, but no problems. It's got an over limit, but no problems, it looks like. It's good for about 600. Getting no damage to it. So these are the first 3 casualties of testing. These are all damaged during our ESD test. You can see here. So you're walking across the carpet and you touch the inputs. Yeah, may not survive. You can see here the front end's damaged on these two, and the X-Tech won't even power up. I'm not too surprised for the Unities, but you know, this one here, much cheaper meter, no auto ranging or anything, held up just fine. So these are the 2 Unities. Here we have the D model, and here we have the E model. These are both damaged by ESD. What's interesting is you can see the designs of these two are significantly different. You know, in my previous videos I had tested a Unity 139C. I and it failed very early on in the testing. I'm not really sure where, again, because I didn't have a way to program the waveforms back then. But you know, that meter, the 139C, I would say was on par with these. These have data logging ability, but that 139C did not have. But you know, these aren't bad meters functionality wise, but all three of these Unities had failed very early on in the testing. I mean, these were taken out by ESD off that piezo grill, which I said, yeah, you got a pretty shitty meter if it can't survive this. So that's where these are on par with. But this one here, also from Unity, this is the UT90A, very low function meter. It's all manual ranging. This meter here survives this testing just fine, along with quite a few other tests. Again, made it into my final four, my original meters. Very low end Unity, surviving. And these ones here, which are actually a nicer meter functional wise, can't survive even the basic tests. So I looked at both meters. I definitely fried some of the input circuitry. I'm going to attempt to repair one of these. We'll do the E model. It's a higher end model. And these two diodes here are definitely shorted, or appear to be in circuit shorted. I'm going to change those out with the same M7 diodes, and we'll see if we can get this thing back online. If I can, what we're going to do is do the DC volt test and then the rectified AC volt test. Just be interesting just to see if one of these can go a little bit further in the rounds. I will be using the same M7 diode, so yeah, it'll be a swap out, but the part should behave basically the way it was original. So let's just see if changing those out will fix it. These are our two diodes out of the Unity. Let's just see if they are short. Ooh, they're not. Okay, so that's not the problem. So I looked over the rest of the board. Diodes all seem fine. Yeah, it's not really worth my time to try to figure this one out. But it is kind of interesting. You look at all these placeholders here. I believe these are all for MOVs that were never installed. I think the meter would have survived had these been installed. Hard to say. It's just amazing how poor some of these Unities are versus this one here. Again, that is pretty much bottom basement and continues to work okay. Yeah, it definitely doesn't die on these kinds of tests that these failed on. So I'll put this back together along with the other one, and here's the E model back together. You can see here in resistance mode it reads about 25 meg. Could be that large resistor is actually broken down. See, it's overranged here. Some of the modes I think actually work with this, but yeah, as a whole the front end appears to be blown. This is the D model. You can just see how different these designs are. You know, this unit, I believe the control IC is dead. That's partly why I looked at the E model. When you run this one, you can see here it's reading hertz. This is in the volt range. You can see millivolts. Yeah. Nice, huh? Yeah. I'd never buy a Unity meter, I'll tell you. These things just very poor. And I don't know why they would make this thing here so hardened and these better meters so crappy. This is the X-Tech 530. And this meter, again, you can't even power up. You can see here, it just flickers on the LCD when you change the ranges, but yeah, that's pretty much it. There's no response to any of the buttons. I suspect we fried maybe some of the control logic. Again, it's not worth really doing much of an investigation. I'm surprised though with this meter. You know, separate circuit board and everything. This one actually has some UL marking on it. UL US listed. I don't know what UL would have done with this, but boy, I'd be holding my head pretty low if I certified this meter and it couldn't even handle some basic ESD pulses. That's pretty poor. Okay, for this next test, we're going to use our generator to output a rectified sine wave. This is the RMS voltage, so 265 volts RMS. And then what we're going to do is take each meter and run them through all their ranges. And then we'll go back and functional test them. In these modes, it's drawing enough current to trip the fault on the generator. So let's just go ahead and turn the current up. Let's see here, the PTC kicked in. It started out about 48 milliamps. Then it slowly declined here to 26. Oh, there you go. So temperature, you see it almost 100 milliamps. I gotta tell you, this UT90A, very cheap meter, seems to hold up better than a lot of them though. No, it's fine. This one's drawing even more current. Oh, there it goes. Look at that. It's totally dead. Oh, back online. That might be okay. We'll just have to see. And we cranked up the current limit even further. This is the TechPower TP2844R, and you can see here it's reading 135 volts, 84 volts with nothing attached. Minus 85 volts DC. So some of the modes on this meter actually still work, but yeah. What's amazing again with these is I would have never thought any of these meters would have had any problems with this first set of testing. So I don't know what I'm going to do with the meters that fail yet. Probably just accumulate them in a pile. Yeah, I would say if you're looking for a meter though, these first 4 that failed probably would not be on the top of my list. You know, the other ones, even though they're cheaper meters still, at least they survive some basic tests. I mean, criminy, you know, you walk across the carpeting and you touch your wires and they fry, or you plug them in a wall socket and they fry. That's pretty bad. One interesting thing with this meter here, it might be difficult to tell, but see where it says MAV, and it's rated across the 2 input jacks, and there's nothing there. It's a common theme. It's like the engineers probably figured out what it would take to make the meter survive, and then somebody said, well, we need to make more profit, so let's leave that stuff out. And if they blow it up, well, it'll end up in the landfill and they'll just buy a new meter. Yeah, I don't know. Is that responsible? I don't know. You tell me. I guess that's why I'm doing these reviews, you know, try to steer you away from low quality meters. Maybe the manufacturers over time will try to improve things, but yeah, I doubt it. I doubt it. The only way it's going to happen is if people don't buy their crap. So these are the meters that have survived my piezo starter test. They've all been subjected to their rated input DC voltage, and they've all handled rectified AC voltage at their inputs with all the modes selected. So of course we have the Bryman here, my Unity, the one that made it into the final 4, and of course the winner of the first batch of meters, the Fluke 101. I suspect these 4 meters here are what's going to fail on the first initial rounds of transient testing. And the reason I say that is each one of these meters had a problem with the ESD testing. So while they didn't fail, they still work fine. Just the fact that that little bit of static charge caused these things some issues, I don't hold out a lot of confidence that these are going to survive that first round. I think these 2 here are going to do very well. This is the amp probe, the 530, Again, very similar to the 510 that I've got. I don't know why the continuity mode on this is so poor. I actually did that as part of the video. I was touching the leads and I was like, wow, this thing is really poor. Just what 5KY had said. I couldn't believe it because my 510 is lightning fast compared to this thing. Another thing that's kind of interesting is how large this 107 fluke is to this 101. I wouldn't have thought that, but you know, there's more circuitry in there. Hopefully this will do very well though. I doubt the B&K is going to do well just because of my experience with the first one. But these are my picks right here. But you know, again, these are all $50-ish meters, so you know, I'm not expecting a whole lot. The Bryman here I'm expecting is going to go pretty far in this. I doubt we're going to have any problems. This is actually, I've had this apart and it looks like a very well built meter. But yeah, we'll find out. We have to test them to really prove this. So, alright, so I think that's going to be it for this video. Try to keep them semi-short and hopefully filled with some useful information. And we'll go ahead and take these and start our first round of transient tests.